Back.
So you're back.
You're back. No, that's right before.
Okay, I am recording.
You're just now recording.
So don't say anything that you don't want recorded.
Okay.
Okay. Part 1, numero uno. What is simple linear regression? It basically is just like a XY relationship between two things.
Mm-hmm.
So like one thing is the dependent variable and one thing is an independent variable, and you show the relationship between the two, and it shows, I think it shows correlation.
Yeah, well, it shows the independent variable and the dependent variable. So
right,
it shows the relationship between the two.
Right.
And if there is like a correlation, if there is like a trend.
Right, and if there is correlation or a trend, then you'll see like the points of your data in a straight angular line.
Uh-huh.
Mm-hmm.
And you can manipulate the XY axis to make it a perfect line, pretty much.
Yeah.
Like if you change the, like if for the example they do in the prep, it's like head and body length.
Mm-hmm.
They manipulate the units of the x-axis and the units of the y-axis to make a good line.
Mm-hmm. Okay.
Yeah, anyways, that's a later question, but
okay. 2. What's the formula on the wiki in terms of y,
y hat,
b1, and x, which represents the linear equation used to estimate the line relating the variables x and y? So it's the y hat equals BO plus B1x.
and I'm not totally sure what B naught is.
Yeah, I think we're gonna kind of start figuring that as we go.
Yeah, I watched the video and he said it, but I just am not remembering, because B1 is like the
so if you look at the next, well, I guess that's not. Never mind. Let's just keep going and we'll see.
Okay. Danielle, you want to do 3?
Yeah. It says, I'm sorry. For the line J equals 1.34 minus 2.2x, what is the slope? Slope is, how do you pronounce? Is how
slope. Uh-huh.
Slope. So the slope is 2.2.
It's
right?
negative 2.2.
Negative. Yeah, 2.2.
Because it should, if you go back to the question 2, the equation should be y hat equals b naught plus b1x, and so there has to be a negative 2.2 to make it 1.34 minus 2.2.
Right. So it's minus 2.2.
Correct.
The slope, yeah.
And then for y equals 1.34 minus 2.2x, what's the y-intercept? 1.34.
Mm-hmm. Okay, and then 5 is using the prediction line above, and number 4, predict the value of y and the input value x equals 5. So I just put in 5. You get 1.34 minus 2.2 times 5 equals negative 9.66.
Correct.
Mm-hmm.
Okay. So part 2.
So we
what
already,
is that?
We already did this crocodile one. This was like last meeting.
Yeah. I think we're just answering questions about the same thing.
Mm-hmm.
So what's the explanatory variable? If you're
head length.
Yeah, because they're trying to determine whether body length is correlated with head length, so they're putting in the head length as their x.
Yeah.
So that's the explanatory variable, which is like saying the independent variable. And then
because you're trying to predict body length off of the head, so the head length is what really is your predictor.
Right, it's independent of body length, but we're saying that body length depends on head length. So body length would be the dependent or the response variable. That's for question 7. The response variable is body length.
Yes.
Yeah.
Response variable. Create a scatter plot representing the relationship between the head length and body length. You guys, hold on. I don't have the thing open. Let me open it up.
No, we did it before, and I have it on the key, so we can just look at it. I'm just gonna share my screen.
Yeah, because you just click the things and then click scatter plot.
Yeah, we did it on Tuesday, but that's what it looks like.
Yep.
Yes.
Okay. What are we on? 9.
Yeah.
Yeah.
Use the software in the computer to find the y-intercept. This one I do want to do, just to make sure I know how to do it.
Yep. I'm gonna do it also.
Oh, spreadsheets. It's the inference one, right? Oh no, the data analysis.
Quantitative inference, I thought.
I think yeah. Yes, it is quantitative inference with linear regression.
Right, you are. I don't know why it doesn't want you to copy it sometimes.
Oh, that's weird. All right, hold on. What's the first part of the crocodile thing? The gharial. What the heck is a gharial crocodile?
The head.
Probably the type of crocodile. I'm gonna look it up right now. Because Google.
Gharial. How do you pronounce Gharial? Gharial?
No, sorry.
It's a fish-eating crocodile.
Is it little?
No.
It's this. Am I still sharing my screen?
Yeah.
Okay, it's coming up. The picture's little.
I have my screen unlocked, but you guys are still not. There we go.
Okay, these are the gharials. Oh, they're the long-snouted ones.
They're creepy faces.
Yeah, they're really creepy.
Creepy faces.
Look at it. It's a creepy face. Look at that thing.
Ew.
Okay, so we're supposed to.
Look at this one. Hold on.
Oh, there's another. That's a wicked. Those are weird.
Yeah, it's got a weirdy nosy.
Don't like it at all. I feel like you could hold its mouth closed with one hand.
Yeah. Oh, look, there's a snake that's eating it. Oh, no, it's eating the snake. Okay.
All right, number 9 says use the software to compute the value of the y-intercept in the regression line. So that's the R value, right? No.
The y.
It's minus. It's in B, right?
Y-intercept B.
I think R value is the slope.
R value is the slope.
I think.
So what does the answer key say for Daniela? Do
Here,
you know what
hey,
it is?
look it right here.
Negative 69.
Yeah, negative 69.
It says y-intercept. It's the B.
Yeah, do you see on my screen? It's right here.
Yeah.
Yeah, your screen's tiny. Mine's so much bigger.
Well, then what is this? So then I was wrong. What is R value?
Yeah, it's
That's
minus.
the correlation factor.
The R value could still be the slope. That we're talking about the y-intercept. No, slope
Right,
is 7.4.
Yeah, so slope is 7.4. R value is the correlation factor, saying that this has a strong correlation.
Oh, that's right. I remember
No,
that.
we are in 9?
Yes, that was 9.
Yes. So 9 was...
9 is y minus intercept equals negative 69.369.
Yes.
And then we did the slope was 7.4, which is 10.
Uh-huh. Yeah.
So to put it into the equation, you would just do y hat equals negative 69.369. plus 7.4x.
Mhm.
Yes.
So that is the answer
Cool.
for 11, right?
Mm-hmm.
Yes.
Mm, okay. The 12 is about the scatter plot.
Scatter.
The scatter plot.
Scatter. Yeah.
How do you
Scatter
draw?
plot.
How do you draw a regression line in the scatter plot?
You just do a straight line.
You
It
need to
said-
click on the points and
Uh-huh.
and then you need to, I don't know, remember how it say them.
Is it?
Only in the points in the graph, and
Uh-huh.
then it's like
It's not shift.
you start with T. I don't remember how.
The chart element
Trend line.
Trend line.
Yeah, that
there
one.
it is. Nice. Did he talk about that in the video?
I don't know.
I don't remember it.
I can't remember.
I watched the video, but also had SpongeBob on, so okay. So 13 for the observed head length of 51 centimeters. What is the observed body length? So we go to 51 and then go up, and it's about 300. Hey, that answer's different.
Oh, that's where.
It says 343. There's two of them there.
Yeah. Because there's other ones at 52.
Oh, look at the data file. So you got to go into this thing.
You just
Find
look at my,
51 and it
or
says
you could just look at my
343.
screen.
Yeah.
Yeah.
Cool beans.
Okay. And then 15, why are the values you obtained in number 8 and number 9 different?
Number
I
8.
don't know.
Where are the values? 8 and 9.
Yeah, okay, so because you look at the scatter plot and the y-intercept looks like it's at like, well, it's 200. It doesn't even, it's like a positive,
Yeah,
looks like it'd be like positive 50 or something like that.
right.
Mhm.
Why are they different? I don't know.
Who the heck knows why they're different?
The answer key does. It says the values are different because the points are not all exactly on the same, on the line of best fit. If you look at the graph, visually you can see that the actual point of 51 centimeters is notably above the line.
Right.
The line equation is the best estimate, but it is not the actual observed measurements. That makes sense.
Oh. That makes sense.
Mm-hmm.
So the line that they give in the scatter plot is just like the average trend, whereas if you actually were to follow it down to the bottom, it would be at the negative number.
Yes.
Cool.
Okay.
Quiz time.
Chris. Hopefully we don't need the crocodile data because I just closed it.
I didn't close it. Oh, hey, the first one and the second one are true.
Right.
What are they?
Number 1 and 2 are true.
They're true? Are you sure?
Well, I guess, did you do it?
I don't know. I'm not in the quiz yet. I can't read the questions. Because I read every question meticulously before I get the answer, rather than guessing the answer before I read the question.
Smart.
Because sometimes I do that, you know?
The other way is not an effective way of taking quizzes.
No, it's not. But it is.
But it is
effective way to
kind of
take
how
it.
you, I guess it is like the way that you prove things in statistics,
Yeah.
is you have to set a null hypothesis and prove it wrong.
Mm-hmm. And
So-
sometimes I can't prove it wrong, so that's the one I go with. Which is why I historically haven't done super amazing when I test. All right, I got the math data files open.
Hey, so do I.
I'm copying them right now.
I think I did.
You won?
You beat us?
I copied the things in the.
No, you didn't.
the data in the linear regression thing?
No, you didn't do it.
What?
I did it.
I'm sorry. Today I was a little confused because here is 9:52.
Oh, sorry, it's so late.
No, it's okay. But I was so confused, and yeah.
Oh, when we weren't online?
What?
When we weren't online doing the thing?
I was, for the reason I sent how do you say, message?
Message.
Because I was a little lost. Give me a minute.
You were a little loca.
I
Okay,
need.
give it.
I don't know how to say conectar. Okay. Yeah.
Excellent. Okay, 3. Given the linear regression equation y equals 2.0 plus 1.5x, what is the y-intercept?
2.0.
2.0. Right?
Yes.
Yeah, 2.0.
4. Given the linear regression equation y equals 2.0 plus 1.5x, what is the slope?
1.5.
Correct. Given the linear regression equation y equals negative 3.0 plus 0.25x, what is the predicted value of y when x equals 16?
1.
I did it in the calculator, and it is 1.
Dude, you can do that
Okay,
in your
1.
head. 0.25 times 16 is 4. Negative 3 plus 4 is 1.
Well, I sometimes, every time, make mistakes with head math.
That's why my Algebra 2 class is so fun here, because the teacher always made us do stuff in our heads.
Yeah.
It was always like, you can do this in your head. Like, don't rely on a calculator, because they're always going to rely on a calculator. You can do little bits of math.
True. Like, you can do little bits of math, but I also make mistakes every time I do math in my head.
He made mistakes all the time, and it was so funny.
Okay, make a scatter plot.
It's hot dog shape.
It's hot dog shape. Are you sure?
It looks hot dog shaped to me.
Yeah. But why isn't it a hamburger?
Dude, it's long and thin.
Okay.
Dude, Ivan, quit chewing on my shoes, you weirdo. They're my shoes, and they're on my feet right now. Or is it banana? That's not.
It's
I
not
don't
banana.
like
No, I think it's
because that could be a hot dog just turned like that, or a hamburger turned like that.
Yeah, exactly. It's a little bit on the angle.
Like the buns and the buns, yeah.
Yeah,
Weird.
that's what I was thinking. I think it was buns.
Weird.
But it's also hot dog buns.
How do you pronounce hot dog?
Hot dog.
Yeah.
Like hold on, like a
Caliente.
wait, perro caliente,
Perro caliente. Yeah.
or is it perro calor
Caliente.
caliente?
Dude, it's a
Yeah.
caliente dog. You're making fun of us in our
How do you
Spanish.
say burger in Spanish?
Hamburguesa.
Oh,
No,
so
you're saying hamburger.
yeah, you're saying just like a fancy hamburger.
Hamburguesa.
Yeah, it's just like fancy.
No, it's fancy hamburger.
Oh, okay. Based on the shape
in
of
Russia,
the
they said hamburgers.
Yeah, they say hamburger.
Hamburguesas.
No, in
Yeah.
Russia, they say
In Russia.
hamburger.
How do,
What is it? En Russo,
and Russo, how they say?
hamburger.
They don't
Yeah.
say H's.
Yeah, they have no
They
h.
only say G's.
They say g or
Yeah.
Okay,
Okay.
you guys quit playing around. Based on the
Yeah,
shape of
based
the
on-
scatter plot you produced in the last question, what can you say about the what?
appropriateness. of using
to keep it
simple linear regression.
Just the actual part, like if your upper arm or lower arm.
Is the first one? Simple linear regression is appropriate for this data.
Seems appropriate.
Yeah.
How many observations are in the data?
Simple linear regression is appropriate.
I think so. Where's the observations?
I think it's the number of, I don't know.
Well, this is what's the number of observations? Is it the number of things we put into the system?
I think so, and I think it's supposed to tell us, but I don't see it.
It's 139 if it's the data, like the number.
Where do you see 139?
Well, it's 142 minus 4. 3, 4, minus 4 because it starts in, well, it's minus 3 because it starts in cell 4. Yeah, that's 139. But where did you get that number? You're crazy.
Wait, did you just know it, or did you find it in your...
In the
Wow.
I think
Excel
she got it
thing.
from,
Does the Excel sheet say it?
Yeah, no, like not say, but I.
Oh,
Like-
she did it. She did it in her head.
or she just scrolled down and looked and it stopped at 140 and it started in cell 2.
So 139?
Yeah.
Hope so.
What is the y-intercept?
18.6.
What?
8.6, are you crazy? It's 1.296.
Oh, 1.296.
It's that or not?
It's here. Look at it. 1 second. It's right here. Do you see it?
Uh huh.
Daniela, where did you get that number?
1.296.
I don't
Where did you
know.
get 8? Hey, it was her null hypothesis.
Did you say
And we proved it wrong.
16.369?
1.296. Right?
Yeah.
Yeah.
And the slope is
Okay.
0.042.
Or it's 83.620.
So it's 0.42.
Yeah.
See?
Yes.
Yeah.
What is the predicted value of y when x equals 4? Oh,
That is-
predicted value.
Oh, so our equation is y equals
Yeah, we can just plug our stuff in.
y equals
Hey, why don't you do this in your head, Jack?
1.296. This isn't simple math.
So when x equals 4,
Yeah.
We can only.
So it's y equals 1.296 minus 0.042 times.
wait, why is it minus? We
Isn't
don't
that
have a
what it
negative
always is?
slope. We don't have a negative slope. It's
Oh, yeah.
normally plus,
Yeah,
unless you have a negative slope.
fine.
So I think it's 1.464.
Well, my phone's my calculator and I can't get to it right now, so I'm going to trust you. What point what?
1.464. Because I did
You did
I did
1.296 plus
1.042 times 4 plus 1.296.
Okay. 1.464.
Yeah.
What is.
I know that they do this, the y-intercept first, but it's dumb.
Can you put, there must be a reason for it, other than, or maybe just statistics wants to be different.
That's my guess, is that you don't
They're
say
like-
that it's point or the slope intercept form.
We're special math.
Okay.
I like this math because it's pretty simple.
Yep.
It's
And
not-
I like it because somebody else figured out how to make an Excel file.
yeah, someone spent all the time to do that, so you just have to put in numbers most of the time.
Yep.
until something isn't set right, like your confidence level is a little different, or I don't know, there's
Yep.
a variable you didn't change right.
Before we do the final, I'm gonna re-download all of the files
To make
just
sure
in,
they're good.
just in case I messed them up.
Mhm. The confidence data resulted from students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for those values of x?
What
Round
the
to third decimals hint. Because there is a positive correlation, we can use the largest x value to find the largest predicted value of y.
that have to do anything with the questions we just did?
Maybe.
Oh, we're still using the data file.
Are we the math one?
Yeah, because it's between all of the confidence scores are between 1 and 6. That's what it's
Oh,
saying.
so the explanatory variable.
Well, farts. Did I have all the data in backwards?
Well, that's what it looks like right now.
Because it's saying
Because what is the maximum predicted value of y for these values of x? And the y numbers I have are the low ones, the 1 through 6s.
gee, dang it. Hold on, let me see what it says. So it says be sure to use the confidence data for your explanatory variable. Farts.
What?
We gotta redo it.
We put the numbers in backwards.
We're supposed to use the small numbers for our x values.
Darn it to heck.
We gotta redo like back from a while.
Well, thank goodness this is easy.
It's not too difficult to read, to just copy and paste it and then read it.
All right, no horsing around this time.
Yeah, Daniela.
This is serious business. They did that to us on purpose.
Yeah, they
Yeah,
did.
they said the
Did you
data-
see the thing? It said, be sure to do this.
Yeah, they're like,
Oh,
psych, we're gonna get ya. You guys are gonna not read the thing right, and you're just gonna
Instructions,
jump ahead,
you're
and you're
just
gonna
gonna
just guess on stuff.
hypothesis this.
All right,
Oh,
how far
look
back
at.
do we have
Oh,
to go?
that's why. Andrew, we were so dumb. She did it right. The y-intercept is 18.690.
Daniela, why did you let us mess up?
She's like, they'll figure it out eventually.
You're like, you guys are gonna submit it and get all the wrong answers, and I'm just gonna sit here and
Oh,
laugh.
and that's why it's a hot dog too, and not a hamburger.
I know that kind of looks the same to me. All right, so okay. What question will you go back to?
Question 9.
6, 7.
9. Those are all
Okay, yeah.
the same.
So 9. What's the y-intercept? 18.69.
18.690. Yes.
Come on,
Okay.
Daniela. Why don't you stop us there? The slope, 12.695. Sorry that we laughed when you said 18.
Now we're the idiots.
But our
Not that you were an idiot.
our predicted value for y when x is 4 is still right, isn't it? No. Nope.
Nope. 12.695 times 4 plus 18.690 is 69.47.
Which makes sense because if you go to 4 on the thing and then you go up to the line, that's where it lands.
Yep.
All right, what was the number
Is
again? 69?
11.69.
69.47.
69.47.
Yeah, I'm going to redo it just to make sure. 12.695 times 4 plus 18.69, 69.47.
Great.
Now we can do it.
So you go to 6 and the predicted value, the highest predicted value for 6 looks like what, 95.
Well, wouldn't we just put 6 in for x?
Yeah, you could do that. And then it kicks out what that number is. I'm just looking at the thing saying it looks like 95.
Yeah.
92.
Plus 18.69 is 96.48.
Ooh. Hey, we're almost done. 96.48.
Mm-hmm.
How many
Okay.
explanatory variables are present in simple linear regression? Just one.
2?
Well, there's only one type of independent. Is it saying like 1x, or is it saying one?
I think it's in the formula, right? So how many variables are?
X only appears one time in the equation.
Is it saying how many different values of x can there be?
That's my question, because I think it would say like
Because it would be way
that
more
would
than
be a
2.
silly
It
question
would be
though.
infinite.
It'd be way more than 2.
Well, actually, according to this, it can
Or
only
it
be
could-
between 1 and 6.
Right. But is that?
But it doesn't say in this simple linear regression. It says how many variables are present
I think
in
simple.
simple
I
linear
think.
regression.
I think simple. I'm gonna look it up.
I think it's 1. That's my vote.
I think so too.
But Danielle thinks it's 2, so maybe we should go with 2 because she's always right and lets us be wrong all the time.
I think it's because have two variables like x and the slope.
Well, the x is the variable. The slope, that just is like dependent on your function,
So,
and so is your.
but look at in the box confidence and prediction interval for regression response. There's an x there, and it says 6 underneath it.
Huh. That would be more than 2. But look at this on Google. Simple linear regression. One dependent variable, one independent variable.
One of each.
One.
I guess that's for simple linear regression. Maybe there's complex linear regression that involves
Hope
more.
not.
Yeah, I don't want to do it. Maybe that's next week.
Okay, we'll try 1, and if it's wrong, we'll blame it on Daniela.
So then 14 is also 1.
Yeah.
Yeah.
15. Company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all the hats they produce for quality control and planning purposes. Measurements they collect include hat size, circumference of the hat, length of the meaning the company wants to predict size of hat given the circumference. What is the response variable? They want to predict the size of the hat.
Right. Based off of circumference.
Because it is the variable being predicted, the size of the hat, the very first one.
Uh-huh.
Mm-hmm. Before you submit, can you tell me again the answer for 12?
Yes. 12 is 96.48.
I don't know. We'll see if that's the right answer.
Yeah, seriously.
We missed one. We missed 12.
Huh.
It's not 96.48.
The confidence data resulted from the students evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? So the very last y? Is that what it's saying?
Maybe.
The maximum predicted y. How can you know?
Okay.
Oh, maybe is it this?
It's 87?
No, I think it's. Do you see my screen?
Yeah, like that 100 something.
117.445.
Yeah, I think it's that.
Okay.
I'm gonna try it, and I'll submit.
All right, I'm going.
117.445. But everything else was right.
Yeah, everything else was right.
Ah,
No?
wrong. What could it be?
No sé.
I don't want to miss another one. I want 100%. I don't want 94.
Absolutely. Predicted. Maybe it's 94.859. Danielle, you should try that one.
I call going last.
Well, I don't think Danielle, have you submitted it yet?
Oh,
Daniela?
she's going ghost on us right now.
Yeah.
It's 87. Could you hear me or not?
No.
Negative.
Darn it.
We need your
Um,
answer.
Andrew, I'll do it. I'm brave if she can't hear us.
I'm not brave. I need points in this class.
No,
I don't have an A right now.
I don't either.
I don't know.
This class hasn't been that
Mm.
difficult.
Oh, that's not right. Can you hear us, Daniela?
What? Did you know you can change the answer on the quiz that's already submitted?
No?
You can click another thing and it moves the guy.
Yeah, and then when you just
Wait, what?
go back.
Yeah, so it's not like it submits a different answer, but if I'm like looking at it to like check my answers, it can be on the wrong thing.
Oh, yeah, I knew that.
Okay, so I just need to make sure these are
You can just refresh the page.
11, 69, 47. Okay, I think I got all the multiple choice ones down right now. Did you submit again?
No, I haven't done it again. I haven't even started putting them in. What are the... Hold on.
Daniela,
Hi.
you're back.
Hey, you're back.
Yeah. I
Did
can
you
hear everything, but you don't.
Yeah.
Nope, we don't hear you very often.
I'm sorry.
That's
It's
okay.
my internet. But
We
I
forgive
get
you.
87.
You did 12?
Yeah, but I don't know if it's 87.
How did you do that?
Got 87?
Yeah, I only changed X in the Excel thing, and it's the predicted is 87. And
You
I don't
changed
know.
X in the Excel and you got 87?
Uh-huh.
What did you change it to?
I'm going to show you my screen.
I have to get really close every time this happens because my phone's so tiny.
Could you see?
Yes.
So it's here.
Yeah, what did you change?
Only 6 here.
Mine was at 6 and it's the predicted says 94.859.
Yeah.
What did you change it from?
I don't know. I think it's because there's the hint say that the upper value for x, like for x is 6, so I think it's, I don't know.
Okay, well, why don't you submit it and see if 87 works?
Okay.
Yeah.
I'm gonna do it because I never seen it
Okay.
before.
Eric, I'll give you the numbers.
What was 5?
5 is 1.
Okay, and then
1.0. Hot
what
dog.
hot dog?
Simple linear regression is appropriate for this data. 139 is 8. 18.690 is 9.
18.690.
12.695 is 10.
12.695.
Yeah. 69.47 is 11.
69.47.
And then we don't know 12. 13 and 14 are both 1. And 15 is the first one. Size of the hat is the
Yeah.
variable being predicted.
No, it's not 87.
It's not
Okay, I'll do
87.
the 94.
Which one? Oh, you did 117. I bet it's 94.859. That's what
94.859. 94.859.
I'm brave. And because there's a positive correlation, we can use the largest x value to find the largest predicted value of y.
100.
Yeah.
Woo!
Yeah, that makes sense. So if you look at 6 and then you go up to where that is, that lands on 94.859. Like,
Yep.
You said 96 before?
Yeah, that's when I put it in the calculator.
I wonder if one of the numbers goes out farther and these are rounded numbers and that's why it's different.
Yeah,
You know what I
maybe.
mean?
So,
Yeah, 'cause
how do you get that?
it's 94.859, and that's just what our Excel file does on its own.
So,
So I don't know why yours is doing that.
yeah. You might
Yeah.
need to re-download the file.
Yeah.
Yours could be-
Okay.
Maybe,
yours could be a
or maybe
bug.
just go Control Z and make it go away.
Mm-hmm.
So do Control Z a few times and see what happens.
Hunnits.
Okay.
So do you need all the things again, Daniela?
I can copy because my computer is so slow.
That's okay.
Mm-hmm.
Okay, I'm gonna stop recording though.
Mm-hmm.